Assalamualaikum, my name is SITI ADAWIYAH BINTI SAPARDI, number registered 33DPE19F1052, class DPE 3B. I choose topic shell and tube exchanger. So, basic concept of heat exchanger. A heat exchanger is a system used to transfer heat between two or more fluids. Heat exchangers are used in both cooling and heating process. The fluid may be separated by a solid wall to prevent mixing, or they may be in direct contact. They are widely used in space heating, refrigeration, air conditioning, power station, chemical plants, petrochemical plants, petroleum refineries, natural gas processing, and sewage treatment. Working principle. Heat exchanger works because heat naturally flows from higher temperature to lower temperature. Therefore, if a hot fluid and a cold fluid are separated by a heat conducting surface, heat can be transferred from the hot fluid to the cool fluid. Two fluids of different temperature are brought into close contact but are prevented from mixing by a physical barrier. The temperature of the two fluids will tend to equalize. By arranging counter-current flow, it's possible for the temperature at the outlet of each fluid to approach the temperature at the inlet of the other. The heat contents are simply exchanged from the fluid to the other and vice versa. No energy is added or removed. Heat transfer depends upon following factors. First, types of material, thickness of material, surface area, types of fluid, gravity of fluid, and flow rate of fluid. So, basic equation defined at the heat exchanger principle. Heat exchanger theory leads to the basic heat exchanger design equation Q equal U times A times delta T, where Q is the rate of heat transfer, U is the overall heat transfer coefficient, A is the heat transfer surface area, delta T is the log mean temperature difference. Calculate from the inlet and outlet temperature of both fluids. Hot in, hot out. So, log mean temperature difference method, LMTD. So, used to determine in the temperature driving force for heat transfer in flow system, most notably in heat exchanger. The LMTD is a logarithmic average of the temperature difference between the hot and cold stream at each end of the exchange. So, the larger the LMTD, the more heat is transferred. The LMTD is defined by the logarithmic mean as follows. Delta T equal delta T1 minus delta T2 over in open bracket delta T1 over delta T2 close bracket, where delta T1 equal TH in minus TC in, and delta T2 minus TH out. Delta T2 equal TH out minus TC out. So, delta T is the temperature difference between the two fluids at the two ends. Delta T1 and delta T2 log mean temperature difference. On calculate, the LMTD is usually applied to calculate the heat transfer. According to the simple equation, Q dot equal U times AS times delta T. So, types of heat exchanger based on shell and tube exchanger. A shell and tube heat exchanger is a class of heat exchanger design. This is the most common types of heat exchanger in oil refineries and other large chemical process, and it's suited for higher pressure application. As its name implies, this type of heat exchanger consists of a shell with a bundle tubes inside it. On fluid runs through the tube and other fluid flow out over the tube. to transfer heat between the two fluids. The set of tube is called a tube bundle and may be composed of several types of tube. Working principle. The working of a shell and tube heat exchanger is fairly simple. One fluid flows inside the tubes and the other through the shell, while flowing the exchanger heat, which means the cool fluid gains the heat from the hot fluid. So, one cool fluid enters the shell inlet nozzle and comes out of the outlet nozzle as hot fluid. Obviously, the other fluid will become cool in the outlet than in the inlet. Okay. The fluid flow inside and tube heat exchanger can be parallel flow or cross flow. So figure 1 shows the typical working principle of a shell and tube heat exchanger. Okay. The above figures show the channels at both inlet and outlet nozzle in the front header. That means there are even number of tube passes in the example. However, there can be off number of tube passes. On that situation, the channel side outlet nozzle will be on the rear header. Increase the number of tube passes, increase the heat transfer coefficient. So, construction. Shell. The cylindrical shell can be fabricated from rolled plate or from pipes. Tube. Tube can be plain tube. Okay. Or heat transfer surface area of the tube can be increased manifolds by using finite tubes. Okay. Tube sheet. Tube of the heat exchanger will be held on both the sides by tube sheet. Tubes will be inserted through holes provided on tube sheet. Tubes are firmly fitted in tube sheet either by welding or by mechanical or hydraulic expansion. So, baffles. Baffles are provided to support the tube to maintain the speed between the tube and is also channelize the fluid flow as per design through the shell side of heat exchanger. Tie rods and spatches. Tie rods and spatches will hold the baffle assembly together. I will also maintain the spacing between the baffles. On end of the tie rod are secured to the tube sheet and other ends are secured in the last baffle. So, component. Tubes. Okay. We have tube, shell side nozzle, baffle, shell, tube sheet, plenum, tie rods. Okay. Then advantage and disadvantage. Okay. Advantage. First, less expensive as compared to plate types colors. Second, can be used in systems with higher operating temperature and pressure. Third, pressure drop across a tube. Cooler is less. 4. Tube leaks are easily located and plug sign pressure test is comparatively easy. 5. Tubular coolers in refrigeration type system can act as receiver also. So, disadvantage. Heat transfer efficient is less compared to plate type cooler. Second, cleaning and maintenance is difficult since a tube cooler requires enough clearance at one end to remove the tube nest. Third, capacity of tube cooler cannot be increased, and fourth, requires more space in comparison to plate cooler. So, lastly is reference. Okay. From Nota Chapter 5 Heat exchanger and from internet. So, thank you.